So just out of curiosity, how many people here have worked with Rust? Has anyone actually given it a shot? It's actually kind of nice to have a whole entire audience of people who have never seen this before. So I want to talk a little bit about Rust and my inspiration for this. I have moved from Perl to other languages on a couple of different occasions. And there are sometimes when you move to another language, you find something that you miss. And this is something that I missed, and I talked to other people, and they liked it too. It's kind of a quirky feature, but we all love it. And today I'm going to play it up, and I'm never going to lie at all. So if anyone catches in here anything in this talk that's factually incorrect, just hold it, right? And whomever was the quietest about things that are factually incorrect will all be invited to fight over who gets to correct it at the end. All right, so here's some background. Perl was released in February 1st of 1952, and I started using it around 2001, the ripe age of super young. I was in high school at the time. Perl at that time was pretty hot. It was one of the cooler languages. It had CPAN, and PHP had nothing like that. PHP was still an inside joke at that point, and Perl's ability to interface with data was really well respected. There was the DBI. There was nothing exactly like it. There were even O'Reilly books on it. So that gives you a little bit of idea of the background to this presentation. But today there's a couple of problems. It's not quite addressing the same needs that it used to. I think a lot of other languages have kind of caught up to the DBI and surpassed it. And we're going to address some of those problems in this talk and how we can move forward with it. I want to highlight that it's not our problem that other languages still haven't caught up entirely to Perl, and I'm going to show you some areas where Perl still stands on its own two legs and does quite well. All right, so before I do that, here's some data to substantiate my problem statement. In 2001, a study of Harvard Research Institute by 300 senior fellows discovered that the primary cause of all our problems facing Perl was it's not addressing the needs that it once did, which is exactly what the last slide said. Here's an example of some of the functionality I want to focus on. In this one, you're going to see how Perl works with letter sequences. This is what I actually like about Perl. I can show this to other people. They can easily wrap their head around it. And no other language can do this that I know of. So if you take Perl, you create a sequence, and you start it with A8, you can pre-increment that sequence, and you logically get A9, B0, B1. Everyone knows what it does. No other language does it. So I think that this is one of the roots of Perl. Now, we're going to have to address some of the problems that are facing this piece of functionality, which you may not have even known existed. Here's one huge problem. Perl sequences only go one direction. You can go up, but you can't go down. There is no pre-decrementing on any of these sequences. Here's another huge problem. The order is specific. The sequence will work if you have a number in the rightmost position. It will not work if you have a letter in the rightmost position. That's a real gotcha. I don't exactly know why we can't fix that, but you could imagine a sequence that had a letter in the rightmost position, and logically, 0A pre-incremented should be 0B. Does anyone disagree? Totally intuitive. Likewise, even if you have a number in the rightmost position, if you have anything but a letter before that, it doesn't work. So 7A7 pre-incremented, you would expect that to be 7A8, and of course you don't get that. So these sequence generations, I think, have their origin in like Excel, and that's where I find it to be somewhat useful. But the implementation itself also can't seek, and I actually found the implementation in Perl, and I printed it out, and this is somewhat interesting in my opinion, because you can see that the implementation actually supports ebcdic, which it's all based on ASCII math under the hood. So we're actually pre-incrementing a string, and it just so happens to be that B is the next position in the string, which is why this whole charade works. But if you have ebcdic, it's not necessarily the same way, and there's special logic in there to handle ebcdic. So you can imagine someone taking this functionality, which natively supported ASCII, and submitting a patch to the core team and saying, I really need this on my IBM mainframe. This is truly a foundational piece of technology. So I want to recap a little bit on 2000 and what the ecosystem was like. In 2000, people are still using Excel 95, and it runs on pretty much no requirements. The maximum size is 4 gigabytes. Databases aren't weird. They're all row-oriented. We don't have these columnar databases where we need to generate petabytes of sequences. And Perl thrives, even though there's a couple of shortcomings in the sequences that I've already demonstrated. But in 2022, Excel is in the cloud, and we're no longer facing a 4 gigabyte NTFS problem. And now we have a maximum file size of 8 petabytes. And how is Perl going to scale to an 8 petabyte Excel spreadsheet? There's really no way that you're going to generate sequences with the current technology we have, so we need to have something that is more scalable and supports better sequence generation. So here's what we're going. I have a thesis here that we need a new method of sequence generation, and it needs to scale to petabyte-sized Excel spreadsheets, and we need to solve the long-standing problems that I've already mentioned with sequences. So I'm going to be doing this with Rust, and Rust has a lot of different advantages. One of them is that it's memory safe. That means that in Rust, you don't have to have the same concern for things like free after use and these types of memory problems that make C a lot more difficult than Perl. At a really high level, in Perl, you don't handle memory management. Everything is reference counted. So when you have a variable in Perl, there's a reference count associated to it, and only when that reference count is 0 is that variable freed up. But there's overhead in that, right? So now you have an internal counter with every variable in Perl, and every time you reference that variable, that internal counter gets incremented. So if you ever wonder why XS is faster than Perl, a pure Perl module, the reason is because there's a lot of overhead with doing very basic things in Perl, so we don't have to manage our own memory. Rust has a different approach for that, so it's somewhat appealing. Because in Rust, like in Perl, you don't have memory problems, but rather than Rust having a runtime overhead like Perl has, it has essentially an education overhead. It's remarkably difficult, and I would say it's somewhat unproductive to write programs in Rust, because you as a developer are going to be fighting with a compiler and these types of things. You're going to have to think about these ahead of time. How do you want to model that? And then Rust will tell you when there's a problem. So what I did is I actually created a module on crates.io, because like I said, I use Rust as well. I've moved somewhat heavily in that direction, and there isn't anything in the Rust world that could do basic letter sequence incrementing. So as a quick little demonstration, I created letter sequence on crates.io. Crates.io is the Rust version of NPM or our version of CPAN. So if you go to crates.io, you can see hundreds of thousands of different Rust packages people have contributed. I kind of think that this is a real great advantage that Rust has over C, in that C never really evolved a repository, right? So one of the great things that I like about Perl is we can go to CPAN, we can download whatever type of code we want. When you go to a different language, right, that predates Perl even, like C, and you don't have that resource, it becomes very painful very quick. Rust has that resource with crates.io. So I created a package here that implements this functionality, letter sequence. You're welcome to check it out. I'm going to give a quick overview of how that works, and maybe I'll show it off at the end. What we have here is a sequence. And internally, a sequence is represented by a starting point, right? An ending point, the inner point, which represents your state inside of that sequence, a step. So in Python and in some other languages, you have a notion of a step. And essentially, what a step does is it says rather than going 1, 2, 3 with a step of 1, you can say I want to do a step of 2, and then you're going to go 1, skip 2, 3, skip 2, 4. Skip 3, 4, and you can specify those types of things. So this functionality that I've created now allows us to have a letter sequence of A to Z, and then we can skip 2. So I can say A, C, and then we've skipped B in the process. There's also a little bit of overhead there with regard to whether or not the sequence is initialized. I store that in a Boolean. Whether or not it's done, I store that also in a bool. And then this thing called a renderer. And basically what I've done here is I have this notion here of a very simple number internally, and I can render that number as an uppercase sequence, a lowercase sequence, or a numeric sequence. So you can change that render at any point in time and change the way that 64-bit integer is represented. Now this is entirely different than the way Perl does it, because Perl is just doing ASCII math, right? So it's literally just saying add 1 to an A, and we hope it renders as a B. And if it doesn't, we have special logic that assists an EBCDIC. The problem with that method is you can't ever seek. So you can never say, get me the 100th thing that comes after, A0, or something like that. In this library, you can, because rendering is separate from the internal state. So the way an iterator works is you have this thing that stores state, and every time you call next on it, you get an element back. So here's just an example of the element. The iterator may look a little bit big to you, but the element is literally just a 64-bit integer and a pointer to this thing that knows how to reference it effectively internally. So the decoration up at the top just says that I can tell if two elements are equal without writing that code. And I have the ability there to debug it, and it'll dump out the internal representation of that code, kind of like in a JSON format. And the last real component here that is on a simple sequence is the sequence render. And essentially, this just stores the render display, which could be numeric, uppercase or lowercase, as I've stated. There's also a capacity for the most amount of characters you want that rendered as. So like, let's say that you don't want to go above ZZZ. You can specify that the capacity is 3, and anything that increments above ZZZ will say you've exhausted the rendering functionality of the sequence. The minimum length also tells you how big, how small you will accept it. This only really works in numbers, and it didn't occur to me until later on that in a sequence that has letters in it, A isn't actually 0. So you can't just pad with a letter sequence. Anyway, if you think about that, it will hurt your brain. There are some problems with using letters instead of numbers and not having a 0. So the way that Rust works is you kind of have these structs, and structs essentially are data. So when you write code in Rust, you primarily think of what do I have to store, right? It's a nice way to think about things, and I would say that Moose and Moo have done something to bring that same kind of model to Perl. You think about storage first, and then what you do is you say, what do I want to do? And you come up with these things that are effectively roles. So if you've ever used Moose or Moo, you have roles, and in Rust we call them traits. So we're going to take a trait, which is a piece of behavior, and then we're going to implement that trait on top of your struct, which stores your data. So I'm going to say, with this data, I can do these things. And there's a bunch of them for Rust, and this isn't going to be a foreign concept if you've come from like C++, but one of those traits is iteration. And essentially with an iterator, all you have to do is say, define what is going to come next, right? And here's an example of that. So I can tell you what I'm going to be doing based on my done flag, my initialized flag, and my inner flag. And really quick, it's pretty simple. If it's done, I'm just going to return none because there's nothing for me to do. If it's uninitialized, I'm going to initialize it, and a step in the initialization, I'm going to return the current state. And if it's already initialized and not done, then what I'm going to be doing is incrementing the internal state and returning that. Okay? And there's a lot of different ways you can do this, and someone could probably critique this for not being effectively optimized. Maybe I could shed a flag or something. But this gets the job done. And lastly, when we talked about these sequences, I demonstrated earlier that one of the problems in the Rust sequence is that you can't have something like A9A or 9A9, these 3 different combined things, even though if I asked you what is the intuitive way to increment that, a lot of people would know it, right? The intuitive way to increment 9A is 9B, even if Perl can't do it. And the intuitive way to increment A9A is to A9B, again, even if Perl can't do it. So we have created a combined sequence struct, and essentially a combined sequence just contains 1 or more, 0 or more actually, internal sequences. So these sequences that I've already explained that can be represented in numbers or lowercase or uppercase, we can contain multiple of them in a bucket. And of course, we again implement the iterator pattern on that, and we say what to do when we call next on it. All right, so here's where we're at. If anyone has Rust or they have access to the letter sequence crate, this is how the combined sequences work, and this is working today. We have Z9ZZ, and if you increment that, what happens? You can actually, first you're going to get the Z9ZZ back, and then the second time you increment that, you're actually going to roll over the first series of 2 Zs to an A. Then you're going to roll over the 9, because you have to carry to a 0, right? And then you still have one more because now 9 is also rolled over. And so you're going to roll over Z, and what does Z logically roll over into? AA, right? Because it's a letter sequence. So you go A through Z, and then AA through ZZ, and then AAA through ZZZ, and so on and so forth. And also what we've done is I incremented plus equals, so now we can seek effectively. You can also do this with nth, which is a Rust thing. So you no longer have to manually do the ASCII math every time you're incrementing the internal sequence. We can essentially just say, set the internal state of this iterator to, 5 billion or whatever. It's a 64-bit integer. And whatever you choose, it will automatically render as that only at the end, right? So you don't have to go through the process of calculating it by iterating all the way through it. So seeking is pretty cool. And I've created this module here called Perl 6 letter sequence. I have no idea if it'll land in Perl 6, probably not, but I'd like to think that Perl 6 will accommodate this very useful functionality. And in order to do this, what we have to do is we have to now have this thing called FFI Platypus. And I've been told that there was actually another talk on that, and I don't know all what was covered, but I will say that when I came to the Perl conference in 2019, I saw the talk on FFI Platypus, and that's what I got into. So the talk was extremely useful then, and I hope someone went there and pulled something away from it now. If you're using a language like Rust, FFI Platypus will allow you to very easily integrate that Rust code into your Perl programs. So you can have things that work faster and are memory safe, just like you would if you wrote XS code. But there's a little bit of work to do on that, and it's really not all that bad. What you do here is essentially when we have this function that wraps our Rust library, it looks a little bit not like Rust, but it's not nearly as bad as XS. So if you've ever done advanced Perl programming, you tend to write libraries in C, and then you tend to wrap those C libraries with XS code, right? It's a very common pattern to integrating C code into Perl. Well, you could write the whole thing in XS too, but you have to bridge your C code into Perl with XS. And XS is essentially the Perl compiler. I mean, it makes everything available to you. FFI is not like that. FFI is more like a shim, if you want to think of it like that. So FFI is a layer that exists outside of Perl and outside of Rust, right? And it essentially tells you how to take one type and get to another type. And this is also somewhat ubiquitous outside of Perl. So we are integrating now Rust into Perl, but some people may also use Python, or they may use Node. And if you're using those other languages, they all have FFI bindings too. So if you can master this art of FFI, you can integrate anything you write in any compiled language into any other language, because it's the same pony show in all of them. So what we're doing here is we are taking a start and an end string, right? Essentially, I mean, without going into too many details, Perl tends to transfer everything as like strings. It's pretty normal. So what we're doing is we have a starting sequence, right? Think about like AAA, that's a string, and ZZZ, that's a string. And I'm providing these two strings into the sequence constructor. And then that's going to construct an internal sequence. And then the only thing Perl has is a pointer, right? So what we're doing here is I'm saying from the constructor, make these two Perl strings, right, C strings in Rust. These two pointers to Perl strings become C strings in Rust. And then, of course, another interesting problem with FFI and with compiled languages is they don't tend to be variadic. So in Perl, you can have one function support any amount of arguments, and in C and in Rust, you really can't, right? So how do you get around this is I say that my third argument is that step that I showed. And if the step isn't set, it's going to essentially default to 0, right? There's not going to be an argument there. And if it defaults to 0, I just change it to a 1. And then I call this totally regular Rust code at the bottom that says let sequence equals. We create a sequence builder. We set all the arguments to it. That looks exactly like it would if you were writing Rust code. And then the bottom is also some FFI voodoo. We essentially say this Rust sequence that you've done store that in memory, right? And more or less leak it so Rust doesn't ever deallocate that, because that's no longer Rust's memory. That's going to be Perl's memory. And we return it as this regular pointer that is marked up as csec simple. Now, that handles the shim between FFI and Rust. And I know that that's kind of an advanced topic, and this is going to look a lot easier. And this is just the shim between Perl now and FFI. So we've handled one of those shims. We have one more, the interface code between Perl and FFI. And keeping this really simple, what we're going to do here is we say that we're creating a new type, and that type is a Perl object. And it's going to be called internally in future FFI actions, csec simple. So that's a simple sequence. And here's where I say that I want to attach to that package a new and a next, right? So I'm in letter sequence simple, and I'm creating two different methods. And the new method is going to take 3 strings and a U32, right? So how many people know here the first string that a constructor gets in Perl? Anyone ring a bell? Okay, the first string that every constructor gets in Perl when you call new is the package name. So that's what you're seeing here, right? The first variable that comes through in new is the package name to Perl. The second variable, the second string that comes through is your starting point. And the third thing that comes through is your ending point. And the fourth thing that you may choose to send or not is the step, right? By the way, this is similar to the syntax that you'd find in I think JavaScript and Python both support the same, start, end, and then step for creating sequences. And then what I'm going to do there is I'm going to say next is going to take as an argument the object, right? Because that's what is the first argument in every method call in Perl is the object itself. So I'm saying that object is csec simple. And then it's going to return a string, which is going to be whatever the representation is of that element that I showed earlier. So internally, you call next. Next returns a Rust element. The element can render as a string. And if we go back to the actual code, which I don't have here, but I can show in another screen, the code for next actually says this integer that I'm returning is an element. I want to render it as a string. So it's actually using the internal renderer and rendering that integer as a string. And that's what I have here. So those are the two kind of methods that are needed for a sequence. Constructing the sequence and then getting the next thing from it. Now in the Rust world, I've implemented all of them. So we can skip and go backward and all that kind of stuff. But the Perl shim is, this is just trying to keep it simple for now. So, and all of this code the Rust code is already available online. And the Perl code I will make available pretty soon. So the work to be done, we need to, what I want to do yet on this package is I want to create essentially a sec binary, which I've almost got. If you've ever used the utility sec in Linux, it'll allow you to create a sequence between two different numbers. So you can say sec 0, 10, and it creates an inclusive sequence 0 through 10. I have already, this is already done, it's part of that package. I've already rewritten that to support letter sequences now. So you can actually say sec AZ and it'll generate a sequence from everything from A to Z. And you can mix them up too, like I've shown in earlier parts of the slides. The combined sequential functionality for Perl, I haven't yet tested that. So some of that is there and some of it's untested and some of it is not working. And then, I think that their world piece is definitely the likely outcome of this module. And then I have information if anyone has any questions on this or you want to use it. I really see one of the greatest things that we can do with it, other than generating awesome sequences in Rust and generating faster sequences in Perl, is using it as an example of how to integrate Rust code with Perl. Because outside of the official FFI packages, there's really not much information on it. So if you have an interest in learning Rust and you want to extend Perl with it, it's a great way to do it. And there's a lot of really cool stuff in the Rust world that we can use in the Perl world. All right, that's all that I have. I can split off and show some quick demos if anyone's interested. Or we can go straight to questions if anyone has any. That makes it easy. There's one. Ah, okay. I should have started off with that. FFI is a shim that allows you to integrate other code in compiled languages inside of Perl. So Perl is a dynamic language with the overhead that I mentioned earlier, ref counting. Other languages compiled, they're not dynamic, and you get an actual executable file. The CPU processes it, you know. There's methods in which you can take executable files and libraries and pull them into Perl and say, I want to call these functions with my Perl scalars, you know. So if you have a Perl scalar and that scalar says, you know, hello world, and you want to call into a compiled library and provide it, that hello world, FFI is one method in which you can do it. The best method, in my opinion, in which you can do it. So do you ever see modules on CPAN that are called XS? Okay, so XS is another method that you can do it that predates FFI. XS is a method in which you can do it where you're actually extending Perl, right, by integrating those functionalities more or less into Perl itself. And FFI is a shimming mechanism where you can call directly into a library from any language, not just Perl. XS is a uniquely Perl thing, and FFI is a everything thing. You find it in any language. I don't know if that helps or answers it. Inline C is not really made for you to be calling C code from inline C. Inline C is made so you can write C code inline in Perl, right? So they have slightly different goals there. If you were going to write a bridge to a library, you wouldn't use inline C. You would use like XS or you would use FFI. I mean, I stand corrected. If people are using it for that, that's awesome. The thing about FFI that kind of makes it different from inline C, or from my understanding of inline C, is that FFI has the ability to do things like specify library resolution and integrate into the build system. So in this Perl 6 letter sequence module I created, when you run make, it's actually going to jump into a directory, download the Rust code from crates.io, compile the Rust code from crates.io, all self-contained, not relying on anything in the system, right? And then link Perl into that Rust code that it compiled, downloaded, and did everything with, you know? So I mean, I'm happy to show that off if anyone has an interest in seeing it. Here's Perl 6 letter sequence, right? And if I go make clean, it's going to get rid of everything there. And I'll show you really quick what it looks like inside. Let's open up the make file. And you're going to see up at the top that I have this FFI build new here. This is all part of the FFI Platypus stuff, which, you know, is really great for the Perl system. And what I'm doing here is I essentially just say at the top this FBMMArgs, and it does everything for me with regard to the building of it. Now I can, at the bottom there's like one more hook that they have you put in. If I quit this and I go Perl makefile, it's going to generate that makefile for Perl. And then if I go make, it's actually going to build it right here with cargo, right? So FFI Platypus actually builds the Rust code from the crate that you have downloaded. So if I jump into that FFI directory and I view the cargo toml, right? This is like their manifest.json file or whatever. I view the cargo toml. You're going to see here that it requires letter sequence, which is the crate that I put on crates.io, right? And that's where it's going to actually know to say, I need to go download that from crates.io. I need to compile the shim which requires it, and then I need to link the shim into Perl. And FFI does all of that, setting up all of the library paths for you to do that type of integration. Yes? There we go. We got a talk on inline C coming up on Friday. What time? I'm not sure. It's the open-ended. Aha, okay. An open-ended talk on Friday. Very cool. All right, I'm happy to show off more of the code. Let me show you here a little bit about what we've got too. This is the Perl side, this is the Rust side. If I wanted to run this, and we could do like, oh, well, of course, the demo gods have got me again. We will fix that later. But there is, I built like a little sequence tool in there, which I thought was kind of cool. Unfortunately, that's not available to see. On the Perl side, that is working though. I can show you what that looks like. If I run code here, here's what it actually looks like to call the Perl code. And you'll notice right there that there is no like C code or anything complex from the Perl's perspective. It's just we're starting the starting point and the ending point, and that can be whatever you like. Oh, there we go. Let's go ahead and give it AAA and ZZZ. And it's going to print out, I think, the first 10 of that sequence, because I have it right here. And you can make it whatever you want, and it'll print out all of them, you know. And you can start it at any point. Like if I wanted to pick it back up at CYZ, CWY, you don't have to, the state gets recalculated. So yeah. Yeah. Happy to answer any more questions on it. FFI or C or Rust. Any of those? It is not. FFI Platypus is a module on CPAN. Yeah, no doubt. I have no doubt this has no chance of getting into Perl 6. This is just the sequence system that I would like to see. It's, yes. I mean what everyone means by Perl 6. I refuse to use the Acme space. Acme is for things that you want to tell other people are a joke. This is a serious piece of enterprising technology to generate petabyte Excel spreadsheet sequences. I mean, I have to start with the foundation. Logically, if the sequence starts at A1, the next thing is going to be A2 for everyone. So the real question would be, if you really wanted a sequence that started at A1 to increment to B1, would it be possible with this module? And the answer there is yes, but I haven't exposed that functionality yet. Yes. So actually, how this would handle this is definitely fun, to say the least. There's a file in here called source sequence, and let me just open that up. And if we come down, you'll see that I showed this in the slide too, that there is a flag in there called done, right? And done means that part of the sequence should not be continued, and everything after that returns none internally in Rust language. So if you had a sequence like A1 and you wanted incrementing of that sequence to not be A2 but to be B1, then what you would do is mark the 1 is done, and then it would go to the next element only and say, can I get it from here? I mean, it's easy to model these. Well, it's not actually easy to model these. I have to say, like the fence post errors, off by 1 errors, when you do something like this, they're like second nature. I mean, there were so many off by 1 errors when I was testing this thing. It was quite amazing. But if you write something like this, I will say that the implementation is probably half the difficulty. Actually finding a way to communicate that to a user is, also not fun. Yes, yeah. I showed that in the slide too. You can decrement these sequences. So finally, we can go backwards from A2 to A1 and from B0 to A9, which is, of course, what's going to happen. Cool. All right, well, go forth and calculate Excel sequences.